Connection looks like it's stabilized. Let's get into it. We're going to skip the intro because I was having some connection problems earlier. So, alright, here we go. Hello and welcome to the third edition of my repair blogs. Tonight we're going to get started on an RT-12. This is a warranty claim. I actually repaired this for someone and they sent it back and said it's still having a few issues. I am pretty sure I know what these issues are. We're going to go over that. We'll go over some of the things I did in this repair, and then we'll see what time it is, and if I have time to get into another one, we'll start doing another repair. So let's get started here. And also, if you guys like these videos, please like, subscribe, and feel free to leave some comments too. Alright, here we go. So from what I remember on this guy, it suffered from glue damage, and it was so bad that the control board for the power supply had to be replaced. That's this guy right here. It's kind of hard to tell because the caps are blocking it, but the replacement board is purple. And that is because I designed and ordered and built these boards, and it's just one of the things that is sometimes needed to bring these back to life. So I covered that design on the Klipsch forums. If I have to make one for one of my repairs I'm doing, I'll do it live. But if you need information on this, I should have everything posted up on the forums. If not, let me know and I'll make sure I get that posted. What I think is wrong with this amp is I think that the resistors are out of spec. And I'm starting to think that on all of these repairs, it's just going to become routine to replace the 4 resistors on the amp board. These guys down here, they should be 330 ohms, so I will get everything disconnected and we'll get into there and we'll start measuring them. They're actually in parallel too, so they should actually measure half of 333. So let's get this disconnected, get started, and we'll get in there and measure them and see what we got. That guy was a little loose. We're going to tighten him up. A little squeeze of the pair of pliers is all you need, and that generally fixes them. You can see we have a little collateral damage on this connector here. So that tells me that one of these resistors was getting pretty hot. Alright. Let's get our trusty Radio Shack meter. Get the light out of the way so you can see what's going on, and let's check one of these. Let's see. Well, we're not off to a good start. Resistor number 1 is showing 5.4 meg and climbing. No bueno. Alright, so we're not even going to measure the rest of them. We're going to pull them all out and we'll measure them when we're done. I think this is confirmation too that all of these need to be replaced. Every repair I'm going to have to start replacing these. This is kind of a new issue. It seems to be happening more frequently. I'm not sure why. It could just be specific to this series of RT amps. I'm not sure if it's prevalent on any of the other ones, so we'll have to see as we go along and do more repairs. But for now, we're going to replace them and we're going to see what happens. I got the soldering station heating up. Here's the nice big and beefy 5-watt replacements, wire wound. These have the flame-proof coating on them, so they should be good for a long service life. I'm not sure if this amp has had any other work done. Removing the glue, it's had a full recap. I believe that is it. Yeah, no trace damage on this board. A lot of times with these, what happens is it'll stop working and blow a fuse, so right away everybody wants to go and put a 15 amp fuse in the fuse holder and power it back up to see if it'll work, and typically as soon as that happens, everything on this side of the power supply just starts to burn. Traces evaporate, parts explode. It's always a good time. Alright. And when I'm pulling these out, I like to give them a little wiggle. Heat it up, wiggle it a little bit, and then suck the solder out. Whether or not it helps, I don't know. It seems to help. I just want to be careful. I don't want to tear any of these through holes out. Through holes are a pain to replace. Actually, I'm going to throw some leaded solder on there just to make life easier. Just dilute the lead free a little bit. It helps. I don't understand why consumer electronics like this need to have lead-free solder in them. I mean, people aren't handling them. Kids aren't really going to be chewing on amplifier boards. I haven't quite figured that one out yet. Same with laptops and, you know, other consumer devices that are prone to solder joint failure. It doesn't make sense why you can't use lead. Especially since all this stuff is soldered by robots now anyways. These resistors do get hot when you're heating them up, so if you are doing it like this, be careful that you don't roast your fingers. But if you keep them moving, flex them a little bit, it makes them a little easier to come out. Alright, all of them unsoldered nicely. So what I'm going to do is I am going to flush trim the leads. Or at least as close as I can get them. The reason I'm doing this is because they're bent a little bit and I don't want to damage the through holes. We're not going to reuse them, so let's make it as easy as we can on ourselves to get these things out. I'm curious to see how many of them are out of spec, if it's just one, if it's all of them. My guess is it's going to be all of them. Alright, so they are loose. Might fight you a little bit, just kind of be gentle, wiggle them a little bit, shake them before you pull them out. Now all these resistors usually have some sign of you know, heat to them. They're going to be a little brown or black, you know, tarnished on the surface, but I mean, these are power resistors. They're meant to get hot. That's why they're sized so big, so you can't really always go by just looking at them whether or not they're good or bad. And I think this is just one of those things that comes with experience. You just have to, you know, find out what the failure modes are on all these things and then work through them. And I've been doing this for a long time and I still haven't found all the failure modes, so that should say something. Either I'm really bad at finding them or new ones keep popping up. I'd prefer to go with option B, but I'll let everybody else decide on that. Alright, so let's get our solder out of the way. Still getting used to the new workbench. the meter in view, and let's see what we got. Resistor number 1. 577. Way out of spec. Let's try number 2. 1 point. Oh, hold on, that was reading my finger. So this one is just open. Interesting. Completely open. Let's try the next one. .8K. So 850. No good. This last one is nice and crispy. I'm sure that this one will be pretty far out too, if not open. Yeah, this one's open. So I just got it between my meter, and if I touch both sides, it'll read the resistance through my body. And if I just go with just the resistor, we have nothing. Shot. So all those are bad. And we'll grab a new one, take a look. Yep, that is where it should be, even with my fingers on it. 330 ohms. So I'll take the blame for this one. I missed this on the previous repair, but luckily every repair I do, I cover with a 1-year warranty, so there's nothing to worry about. And this guy's pretty nice too. Actually, almost everybody I've worked with is pretty nice. I've never really had anybody yell at me, which is kind of nice because I do this for fun, and I like to help people out, so when they start yelling at me, I don't think it'll be fun anymore, which is also why I don't want to do this as a business. So we're going to leave these spaced off as far as we can from the board. They're really out of the way down in there, so it doesn't matter, but if we leave them spaced off nice and far, by the time the heat gets down to the base of the leads where the board is, a lot of it will have dissipated. We don't have to worry about having cold solder joints. Or thermally stressing the board. I've seen a lot of boards on other amp models where, the board will just be like charred and black because the resistors are just pumping so much heat into them. That's one of the main reasons why the R112 and R115 amps fail. You got a resistor that's just plastered onto the board, and then they smother it with glue, and the thing just bakes, and it cooks all the capacitors that are sitting right next to it. Alright. This should be a pretty easy repair. Second repair, the first repair wasn't that easy. Chiseling out all the glue. But I'm sure that once it's up and running again, the owner will be very happy, especially since holiday seasons are coming up and everybody wants to blast their music. If you do own one of these amps, make sure you turn this thing off. That's another big failure mode, and I'm going to say that in probably every video because nobody likes to turn their equipment off. And leaving it powered on 24/7 is really the #1 thing that kills it. Alright. Fire up the soldering iron. Yeah, all of these units have, they call it standby mode, I believe, or I don't know, whatever mode it is. A lot of them have a switch. And while it does save energy, it does not save the amp. What the amp manufacturer does, and mostly these are bash amps, is they mute the outputs. So by muting the outputs, the rail tracking doesn't happen, so the power supplies stay at their lowest levels, but the power supplies remain on. They don't actually shut off. So if you don't shut the switch off, the power supplies just sit there and bake, along with everything else that's hooked to it. If you turn the switch off, or if you unplug it, everything lasts. Alright, we were on 3 of 4. I'm just kind of tacking them in place. I'm gonna hit them with the Weller desoldering tool just so I can get some heat down in there. Get a nice fillet on them. But as far as this goes, pretty straightforward. So our 4 resistors are in. I'm just gonna clean up the solder joints a little bit, just because there is some decent copper planes on there and they do wick away some of the heat, but this guy kind of blasts right through it. Try and get it as close to factory as we can, without having massive solder blobs on there that just look terrible. Again, probably not necessary, but I'm a little OCD and I want people to think I actually know what I'm doing, so we'll make it look good. Making it look good's half the battle, making it actually work is the rest. Alright. So, resistors are in. We're going to straighten them out a little bit. Get them kind of happy and level. I'm going to wipe the white goo off my fingers because it's plastered all over the plate. I'll try not to rant too much about the glue, or the, I'm sorry, the thermal paste. I hate the thermal paste. We'll save that for the next amp. Yeah, we're going to have some time. What time is it? It's only 11:30. I apologize that I do most of these at night, but it's kind of the best time for me. It's quiet. My wife is sleeping. I have a ton of energy. This is a good way to burn it off before I go to bed. So what we're going to do is we're going to bend these power inputs just a little bit away from the caps. Not too much, doesn't matter. I'm sorry, from the resistors. Just try and keep everything a little bit clear. They really shouldn't get hot enough to melt that stuff again, but there you can see them in there, all nicely organized, spaced off the board. And that should have a nice long service life. I'm going to pull them forward just a little bit to get them away from the speaker outputs. Not that it matters, but again, just one more level of precaution. Alright. Let's clean up our conductive metals from the workbench. The owner did supply me with his LCD screen, so we will use his LCD screen. We'll double check the fuse. Let's see what value this, I believe, is 6.3. Yeah, 6.3 amps. Let's see what we got in there. Okay, it is a 6.3, so we're good. Probably the original fuse. Alright, speaker outputs. I still have not got or purchased a small little oscilloscope. I gotta do that. And I want to do an external one, not a PC based one, because if I happen to connect one of the probes wrong, I do not want to fry my PC by sending a whole bunch of power to the ground of one of the USB ports. So we'll just get a little off the shelf, cheapy that we can just aim the camera at. That's a little better. This connector is not cooperating today. Alright, so I'm just sliding the speaker terminals under the silicone. You don't need a super good connection here. We're not going to be cranking this thing up to stupid levels. Just enough to make sure we got clean sound. And I'm going to guess that we had clean sound when I first tested it, but the resistors were probably not as bad when I sent it out as they are when I got it back. It probably was tested and they probably cranked it up and that did them in. They were already starting to fail. They were at a point where they were bad. And that was the end of them. I do not have the intermediate connection cable. Let me check the box again. I don't know if that was sent or not. So that was not sent, but we will use mine. So here's another thing that's handy if you work on these. Make a set of cables. Like this guy here I use for sub 10 and sub 12 repairs. And then this guy, I have it labeled, is for RT. They are different. The pinouts are different for almost all the models. So make sure that you don't swap the cables, because you will end up sending power to the wrong pins, and then you got to replace op amps and whatever else you cook in this, in the meantime. So make sure you're using the right cables. Alright, we're going to power on with no input, because chances are the volume's going to be higher than I want it to be. Alright, everything is properly connected. There is no metal on the bench. Let's flip on our current limited supply and see what happens. Alright, pulsing output. Well, here's a perfect example. So, I do know that will not cause failure on these boards, but this connector here goes down to here. But luckily, the voltage for the plus minus 15 is shared between the two connectors. It's just the input signals that vary. So we do not have to worry about blowing this one up, which is good, because I just gave you a perfect example of what I just told you not to do. Do I want to cut that? No, maybe not. Not yet. Not yet. Let's loop this guy around. Make the routing a little nicer. I really want to get this black wire away from these caps. Yeah, we're going to cut it. We'll redo it. So interesting enough, it came to me with this guy plugged in here, but I even marked it. 2 black stripes on that one. 2 black stripes on that one. So whoever hooked it up was not paying attention to the black stripes. Alright, we will make this a little prettier as we go through. Again, it doesn't matter, but, you know, they had it zip tied from the factory, so might as well zip tie it and make it look nice before we send it back out. Now I just have to find my zip ties. And we'll go with green today. Everybody seems to have their Christmas decorations out already, so we'll go with a green zip tie. Alright, doesn't have to be perfect, just good enough and out of the way. It doesn't have to be stupid tight either, just tight enough to hold the wires in place and out of the way. You don't need to smash the ribbon cable, you know, you want a little bit of flex there. Just a little bit, not too much. You don't need them to be tight, and then the speaker leads need to be free. Alright, let's try again. This time it should be happy. And we're still not happy. Why are we not happy? Let's unplug the input board. Try again. Nope. Let's unplug the amp board. So we're still getting pulsing on the power supply. And our 3 resistors are getting hot. So, we're going to have to dig a little deeper into this. We might have a blown output. I was hoping this would have been easy, but sometimes it doesn't always go that way. Let's check our outputs. The power supply seems to be functioning normally. And right now I'm just checking for shorts. We're looking at the outputs and the diodes first. The T0220 devices. Nothing seems to be bad so far. We don't have any shorts on the FETs. Let's make sure we're plugged into the right spots. CD minus, CD plus, CD plus, CD minus. So those appear to be good. Let's, we will pull the CD minus and check for proper output. Yeah, let's see if we get 8 volts. If we have 8 volts, we know our supply is working. I'm going to guess we have 8 volts. If we have full rail voltage, then we have a blown output. Let's see what we get. Make sure we're not shorted anything. We're just going between CD minus and CD plus. 159, 160 volts. So there is part of the problem. Somewhere along the way we lost one of the FETs. We'll fire it up again just to verify. Yep. 160 volts. So unfortunately, we gotta take this power supply back out. We have to deal with all the nasty goo. And we have to replace one of the outputs. But this happens. I'm not sure what goes on when one of these resistors fail. It could short internally. Not likely. I just don't know. I don't know what happens when those fail, but somehow it killed one of the outputs. And that could be trying to push the amp after that fails. Like, I mean, it could be a number of different things. Or maybe when it fails open, there's a current surge. I do not know. But what I do know is that we can fix it. I usually like to leave the horseshoe heatsink on, so I'm just going to remove the bottom screws first. Be careful when you're doing that. Don't be sticking your fingers in the amp until you drain the caps. They do have bleeders on them, but it doesn't hurt to be extra safe when you're working on this stuff. Now, there is a possibility that the dashboard has failed. We're going to start with the FETs. Usually when you have full rail voltage on your outputs, that is a sign of a shorted FET. Usually when you have no voltage, is a failed dashboard. But there's always a first time for a new failure, so gotta be ready for that one time when it's something different and annoying. Alright, I like to bend the FETs in. So just hit them with the X-Acto knife and just push them off the board a little bit. That way when you're pulling it out, your ceramic heat sinks stay in place. And then all you gotta do is just do a little lift and slide it out. Oh, alright. So we're gonna zoom in on this. This actually did have some board repairs done to it. Let me get that out of the way. And we will zoom in. I can't remember correctly. This might have been a board that somebody else attempted a repair on. Let's see, I think all the way zoomed in. You can see almost all of these had either a trace that was blown or the through holes needed to be replaced. So I had to replace the through holes and then rebuild the traces. This is the trace going from the gate drive resistor. The traces on a lot of these had to be the through holes had to be redone, and a lot of the traces for the gate drives needed to be redone as well. So, I don't remember. I'd have to go back and look at my notes to see actually what the cause was, but I believe that some work was done in here. But anyways, that's what my type of repair looks like. I try to keep it factory. You could do point to point, where instead of following the factory, trace, you can just take a wire from here to here. Some people like to do it that way. I like to keep it as close to original as possible, so I'll run new wires and then I super glue them down to the board. And if it's a long trace, I will pot them in epoxy. These little short ones I usually just leave. They're not going anywhere. They're soldered in two places and they're super glued. But that is how you can take a board that is in bad shape and bring it back to life. So, which one of our outputs is dead? It is going to be either Q5, Q10. We'll check the diodes too, but the diodes will probably read shorted because they are also connected to the FETs. We will do it in continuity. Let me zoom back out. I still need to buy the remote for this thing. I'll work on that. It's on the to-do list. I have a pretty big to-do list. Alright. Here we go, dead short. Now Q10 is only gate and source, I believe. Gate and source or gate and drain, whatever the middle one is. You would think I would have that remembered by now, but I don't. This one's shorted. All three, that one's just on two. And they could both be bad, but we're going to replace them both anyways because they do share current and I want them to be somewhat matched. Try and keep some of that goop off my bench. Whatever the failure was on this, it was a cascading type of failure. The gate drive resistors seem to be okay. That usually means the gate drive resistors are these little guys down in here. These little blue ones that are impossible to see. But they look good. When those burn, you can visually see they're burned. I think those are 68.1 ohms. So we will heat up the solder sucker, pop those out, pop 2 new ones in, check our voltage, see if we get our 8 volts. If we get our 8 volts, we'll put it back together, and then we should be in good shape. And this kind of confirms to me that I definitely need to replace those 4 resistors on every amp that comes in. Lesson learned. Empty out the solder sucker while it's heating up. Now here's a little tip too I'll share. I throw a piece of paper towel down in the back, and I also reload my, I don't know what you call this, I guess a cartridge that holds the solder. Put a little piece of metal down on the inside shaped like a V. Throw a little bit of pink insulation in the bottom to kind of act as the pre-filter, and then I throw a paper towel in the bottom of there to keep any flux residues or anything from getting past the little fiberglass in there. I don't know what the OEM ones are made out of. I still have some of those too, but rebuilding them works fine. They're not expensive, but if I can fix it, why would I buy new ones? I'll get 10 uses out of this, and then I'll go to a new one. Alright, we're going to dope these up first with a little bit of lead. And then same thing, we will heat and wiggle. And all the wiggle does is it just makes sure that you clear the sides that are still in contact with the through hole. That way you're not like stressing it out when you're trying to pull these out, because a lot of times when you yank these parts out, you take part of the through hole with it, and that's kind of a pain in itself. There should be a IRF 540. IRF 640. That was close, only 100 off. Alright, so let's check this one, see if this is the culprit. I'm going to guess it is. Dead short across all of them. And this guy is happy again, but we're going to replace both. Throw a little bit of solder on there. This is where you can be messy. Just trying to get it off. That first one restuck itself, but we can wiggle them and get them free again. Alright. Make sure that this guy is also what he is supposed to be. It doesn't look like it's been changed, but you never know. IRF 640. I always keep plenty of these in stock. One, because I'm terrified that they're going to discontinue them and I won't be able to get them anymore. And two, because pretty much every amplifier uses them. IRF 640Ns. And I'm about halfway through them, so while I have everybody's time that I'm wasting, I'm going to go on DigiKey and add some more to my cart. Just to make sure I don't run out of them. I don't want to run out of them. It's always good to have more than you need. And I always try to replenish my stock as soon as I can. That way I'm not waiting for parts. Let's see, we have Infineon and Vishay. Which one's cheaper? 18 amps. Sure, they both have the they both have the same rating. We'll go with the Infineons because they are slightly cheaper. 20 cents. And luckily the amp doesn't care if they're lead free or not, so we're gonna get 40 of them. Alright. Back to popping these guys in. So what we're gonna do is I am gonna just loosely put them in there. Let them hang, doesn't matter. Since the solder sucker's already hot, we will use this to tack them in. We're only going to do one leg. One leg. And I'll fire up my iron because it makes the job a little easier. My trusty ruler. By the way, I never did drain these caps, but let's see what they got in them. So these bleed off. And this one should be bled off too. Yeah. I should have drained them, but they do have bleeder resistors on them. The only one I think that doesn't have a bleeder on it is the sub 10 and sub 12, the main filter capacitor on the primary output. All the rest of them do, at least from what I've found. Alright, so we're going to get my ruler full of gunk. And at the same time, we are going to line these up and make them sit like they're supposed to be in there. He's sitting a little bit high. Straight enough for me. Alright, I am going to salvage some of the thermal goop off of these because there's way too much on it. Everybody thinks you need a ton of thermal paste. You really don't. Thermal paste is only meant to fill in the microscopic imperfections that are on the back of the device. Otherwise, it actually acts as an insulator. So you really don't need that much of this crap. Just enough to do a nice little coating on the back. Doesn't need to be squeezing out of the sides in like massive layers. It drives me nuts when manufacturers do that. And it makes it a pain to work on because I hate getting that stuff all over everything. It ruins your tools, it gets all over your hands. When I touch my coffee mug, I get it all over that. Which, by the way, it's coffee time. I was going to save the silicone grease rant for later, but later has become now. I hate that stuff. Alright, so devices are in. The first leads are tacked in place. Now we're going to go through and solder them. And I'm using a little bit thicker solder than I normally do. Actually, I'll just use this. I usually like using a little bit smaller solder just because you get a little bit better control at the expense of having to use more, but this is fine. You just gotta take it easy and don't jam huge globs of it in there. You're looking for real nice little fillets. That's what you want. And if it wicks up onto the other side and gives you a fillet there, that's perfection. We have two nice fillets on each one and one blob that was running up the leg a little bit. But we'll call that like 97.5%. Which is better than they did at the factory, so that's a win in my book. Most of these boards, you look at the top side of the board, there's no solder on any of the pads, and all the pads are oxidized and corroded. I would assume that has something to do with the lead-free nature of the solder, but I don't know. Alright. Clean off the pads a little bit. Flip them over. Give it a little eyeball, make sure I don't see anything weird or funky on it or anything burned. I really think that the FETs went out just because the resistors on the amp board started going crazy. And this is only the probably fourth or fifth time I've had to replace those FETs. It's not a very common failure. So I am going to guess that the power supply failed. The resistors were already starting to fail. Then the resistors failed, and then that took out the FETs. That's my guess. And it sounds good, so that's what we're going to go with. Let's turn my irons off. Alright. Actually, we need our meter here. We got to check for our 8 volts. So we will go CD minus right to the connector, CD plus right to the connector. And I have little clips for these, but right now I only have one. The other one's put away, and I don't want to dig them out. So let's see. Can we see that? Give a little bit of light. All right, let's see what we get. Let's power it on. Actually, that's better for my eyes. All right, current limited supply is going on. And we have 12 volts. That's a little bit higher than I'm normally used to seeing, but 12 volts isn't the end of the world. and it's regulating fairly well. Power it down. And typically that output is around 8 volts. But it is regulating, so that tells me that the dashboard is working. The new outputs are working. Let's check the diodes, just make sure the diodes aren't bad. This time we're going to discharge because there probably is still some juice in there. Let's see, let's check the mains. Yeah, we're at 43 volts and dropping, 41 volts. This guy's at 30. They're going down, but we're still going to discharge them. Alright, let's check those diodes. Make sure the diodes are not bad. Alright, should have a dead short to the 2 outside pins. No short to the center pin. So let's go into diode mode and we'll actually check them. So that one looks like it might be a little leaky. I'm going to verify that with my junkyard board just to see if that is common or different. So it's always nice to have a known good board that you can test things like that on. So okay, so we're getting 0.296 on that one, 0.292 on that one, so okay. That one is alright, but on this one, we're getting 0.404, and on this guy we are getting okay, 3.9. So they're within spec. And that's other stuff in the circuit that's doing that. There's probably a cap somewhere in there and whatever else. Alright, so diodes seem good. Voltage is a little bit high on the outputs. Not quite sure why. We can continue to probe though. Let's probe around and just make sure. I'm sure the amp will work at this point, but I just want to make sure that nothing is angry inside there. Let's check this guy for, well, it looks like there's an inductor parallel with that diode. So yeah, that's not going to give us an accurate reading. Let's check the little ones, the small signals. That one is good. That one does not look healthy. So see, good thing we went and checked these out. Yep, we got a bad diode too. So one of the things I did find when working, let's take these out. Those don't need to be in our way right now. One of the things I did find is when these 540s do blow, sometimes this transistor will go. Sometimes the gate resistors will go, the two blue resistors down here, or sometimes the diodes will go. So it doesn't hurt to probe along in there and check and see if something's not operating properly. So we are going to pull that diode out, put a new one in, and then we will check and see if we have our 8 volts again. And I am going to guess that that will probably fix it. Good little reference lesson for myself too. If you don't have the 8 volts like it's supposed to be, something else is probably wrong. They do fluctuate though. I've seen some that no matter what you do, you can only get 5 out of them, and I've never seen 12 though. 12 is a little higher than normal. I don't know what that diode is yet, but I will give everybody the info as soon as I pop it out. So it's this guy right here. Let's see if I can remember that. And I don't have the right tip in, so this is going to be even more fun. Put a little... Uh-oh, that's not good. We lost the tip. If that ever happens, don't pick the tip up. Made that mistake before. You'll only do it once. Alright, I'm going to prop the leads up as best we can. This works better with a number 2 tip. Alright, try to straighten the leads out as best we can after pulling the solder off of them, and that should just help with the part coming off the board a little bit. These aren't too bad to get out. Gotta find my tweezers. Where did I put my tweezers at? So diode D5 is the culprit. We will check him out of circuit to verify. I'm going to guess that it is not happy. I'm going to hope that it's not happy, so I don't have to keep poking around in there. And yes, we have basically a short. We'll go into continuity, and there we go. Dead short. Go to resistance, and reading short. So good. We found another issue. Let's check these resistors while we're in there, just to make sure they're within spec. 68.8, good enough. 68.5. Those are within tolerance. And while we're at it, we'll check the transistors too, just to be sure. So we'll go into diode mode on the meter. That guy doesn't look happy. Alright, no visible signs of damage, yet the transistors have seen better days. One looks good, one looks toasted. Chain reaction of death. I hope I have one of those guys. What is that? Looks like a 4403. I should have one. I'm going to change out to my smaller tip to make this easier. So we need a diode, we need a resistor, or I'm sorry, we need a transistor, and 2 FETs. To get my tips out, I just dunk them in a little bit of water. Cools the tip down and the tip shrinks. Comes right out. Still wicked hot. I'll grab the new one. Just set them in there and give it a twist. Ready to go. Heats up a lot faster that way if you don't have to wait for it to cool down. If you try and pull the tips out while it's hot or you just turn the switch off, it is very difficult to get them out because the heat makes them expand. Alright, while that's heating up again, let's see if I can find the transistors that we need. I have a 4401. I might have to go to a donor board for these. I do not have any 4403s. I believe that's a 4403. It is a 4403. I should have one of those in the graveyard. We should be able to find it. So gate drive resistor was good. Everything else bad. And all of that most likely because I did not replace the resistors on the amp board after repairing the power supply. Ooh, that guy is hot. And these are not the easiest to get out again because of the bent leads. It's just a pain in the butt. Just try and wiggle them without burning your fingers off. And you will eventually get them out. N4403. We're going to have to add some of those to the cart too. I used to have these from other projects I've worked on. We're just going to go straight and check for shorts. Shorted. Every lead shorted. So we'll add him with the 640s that are bad and I am going to go to the graveyard. Let's see if we can do a little picture-in-picture action here. Alright. So I have this board here. Not quite sure what it is out of. Looks like an RW-10 maybe. But this should have one of our donor transistors on it. I wouldn't reuse an output, but these small signal ones are okay to reuse. That's not going to hurt anything. Oh, hey, look, the dog's coming down to join me. Let's see if we can get the dog to say hello again. Come here, Juno. Hey, come here. Come here. Come here. Do you want to say hello? Come here. Nope. Dog is still camera shy. We'll work on it, though. We'll work on her. So, alright, we have a 4403 in the front here, Q708. We will pull that one off, check it, and then transplant it. So here we go. And since this is a board I don't care about, I really don't worry about, you know, tearing off a via or through hole, or I just want to get the part off. But in the meantime, I probably will order some of these so I don't have to do that again, because that's a pain. It's not terrible, but it's enough to be annoying. Alright. Part is off. Check it, make sure there are no shorts, which I don't think there will be. Put the meter into diode mode, and we will check. And depending whether it's a PNP or an NPN, you'll get different readouts on the diode test. And this has a transistor checking feature on it. Will it give you the HFE output, the gain, I believe that is? I don't know. Probably should investigate that more. But as long as you check the leads and you're getting about 0.5 to 0.6 volts as you would a regular diode, and you check that there are no shorts, you're going to have a good part. And I have a printout that goes through, what an NPN should read, what a PNP should read, how to actually, verify it. But, generally, as long as there's no shorts and it's testing like a diode on a couple of the legs, you're good to go. And I guess for while we're at it, while we're here, this will probably be the only amp I do tonight. We could find that and go through it. So here's my little nifty transistor testing sheet, and it basically tells you everything you need to know for an NPN transistor. If you're going base to collector, you should see a voltage drop, 0.4 to 0.9 volts. PNP will show over limit or unconnected, or however your meter decides to show that. So if you follow through that guide, you can get an accurate test just using a diode check. You don't need anything really fancy, just a decent multimeter, and you can check your transistors. So I'm not going to pull the data sheet. I don't remember all right, I'll do it because I have to add them to the cart, and the data sheet will come up anyways. So let's see what this is, and we'll actually run through the test. This is a 2N4403. I do not know what happened. Let's try this again. 2N4403. There we go. It's a bipolar transistor. Package is a T092. We're going to go with we'll go with the on semi. Yeah, we'll go with on semi. They look a little better than the NTEs, and they're coming come in bulk. I like bulk. So let's get 10 of those added into the stockpile, and we'll look at the data sheet. Data sheet shows this as a PNP with emitter base collector, EBC. So it's a PNP with EBC. Let's do a check on it. Sanity check. We've gone this far and found all these broken parts. Let's make sure it's good. So let's go emitter to base. Positive lead on emitter, negative on base. Testing a PNP transistor, you should see a voltage drop. We see 0.663. So I'm not going to go through all of them, but if you wanted to go through all of them when you're testing yours, that's how you can verify it's a good part. I am 99% sure that that's a good part. So we're going to pop it in there, fire up the amp, and see if we get our 8 volts. And then in a minute, I'm going to need to let the dog out because she's crying. So we have our transistor in there. We're going to solder him in. And we're just tacking the lead. We're not actually fully popping them in there yet. We're just going to tack the lead, get them straight. Straight enough. Come on, pup. Lay down. And our diode D5. These things are always so hard to read. I mean, look at how small that is. I mean, it's not surface mount, but it's still hard to read. And it is a 4148, which I know I have because I've used those before. Diodes, through hole. $41.48 right on top. Nice. And I'm going to double check this just to make sure it is what I think it is. It's an on-semi 4148. Let's get a nice bend on this lead here. Make sure it sits down on the board nicely. So I'm going to pop this in, and then I am going to let my dog out. I'm going to try and get her to say hello first, though. 'Cause almost everybody loves dogs. Most people. If you don't love dogs, then I guess that's okay. Generally, I like dogs more than people. Come here. Come up here. Come say hello. Come here. Come here. Come here. Alright, dog is not having it. We're going to tack this in, and then we're going to go let her out. Alright, I am going to throw up the BRB, and I will be back in a couple minutes. I'm going to let my dog out. Alright, sorry about that. I had to let my dog out. So we are going to finish getting this diode in place. And making sure it looks halfway decent. We will do the other legs of the transistor. And this tip is a little large for this. I should be using one of my pointed tips, but I can still get a pretty good fillet on there just by dragging the edge. We will clip the leads straight and not bend them over, because nobody likes people that bend leads. Clean off a little bit of the flux. This flux generally does not have to be cleaned off, but it doesn't hurt to just hit it with a little alcohol. I mean, from the factory, these things are covered in flux anyways. The bottom has white residue all over it. Fairly common thing. Alright. So, we have 2 new MOSFETs, we have a new transistor, and we have a new diode. Everything else should be good to go. So, next step is going to be get all the metal off the bench. Make sure that our irons are turned off. And then we'll fire it up and we will do a... Oh, that looks a lot better. I need to get a little angle on there. Let's prop this guy up. We are going to see if we get our 8 volts. And then I will do a small sound check. And after I do a small sound check, I will test it off camera under a heavy load, which means I will feed it probably 30 hertz into a load bank. I won't feed it into a speaker, I'll just feed it into a resistor. And I will crank it up to about 75% volume and let it run for a half an hour, kind of like a burn-in test, just to make sure that you know, any other bugs that might be in this are found and nothing else malfunctions after it starts getting hot. And I'm going to get this thing pretty hot, so I just want to make sure that before it goes back, that it's not going to come back to me ever again. Not that I don't like the guy that I'm working on it for, but because I want to make sure that I'm doing a good job. Alright, we're going to go to voltage mode. Hook onto the ground. CD plus. Alright. Let's get that 8 volts. We're still at 12. I don't like 12 volts. Something else is acting up, or that diode immediately blew. Alright, problem might still be there. Drain off the caps, and let's see what else is wrong. Let's check the diode we just put in. I know it's a good diode, but we're going to make sure that it didn't blow. And diode is good. Diode is good. Now we can start checking the resistors in the area and make sure these are all okay. 10 ohms, good. 10 ohms, that guy is good. We will check the 4 larger resistors. These are current sense resistors for the dashboard. So they're going to have an extremely low reading. But we want to make sure that it's not open. We will we'll check the gate drill. Let's check that transistor again. Go into diode mode. We'll check both of them side by side. Let's make sure they're both the same transistor before we check them. So actually, we will compare them with our bench board. How's that? In circuit, make sure they're reading the same. Transistor is not the problem. Both transistors are good. Double check both gate drive resistors. What else can we check? We'll check the outputs. Just sanity check, make sure they're not shorted. Good. 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 Alright, so everything seems to check okay. This just might be one of those ones where the output is higher. I just can't see anything physically wrong on the board. We went over all of the components that it potentially could be. The only other outlier is the dashboard, and the dashboard doesn't look terrible. I mean, the glue is turning a little brown, where the two diodes are, but that usually doesn't hurt the amp. I'll tell you what, I'll remove the potting off there. We'll pull some of the epoxy off, just heat it up and take some of the epoxy off the dashboard. See if that changes anything. I don't think it will, but normally I don't do this, but just because it's bothering me that that's reading 12 volts and I'm not used to it, I'm just going to do this and pull some of this off. Just a little heat, 120C. And the stuff just kind of comes off in chunks. And I just mainly want to get it off these diodes where it is starting to turn brown. See if I can quiet down this thing again. It's a little better. That buzzing sound is really, you guys probably can't hear it, but that buzzing sound is super annoying. So, just being careful that we're not upsetting any of the surface mount parts. We're not using a crazy amount of heat, just enough to soften up this epoxy and just kind of pop it out in chunks. And I know the dashboard is working because we're getting a regulated output, so. Is that regulated output wrong because the glue is throwing things out of whack? It's possible. Unlikely, but possible. So we'll just go through and clean it up a little bit. Get some of it off of there. And you do have to be careful when you're doing this that you don't peel any pieces off the board. You pop a surface mount part off the board, you're pulling the board and doing a surface mount repair. We'll get there. It's going to happen eventually. These do go bad sometimes. But a little bit of heat and the dental pick is your friend. Get 99% of that nasty stuff off of that. I don't know why they put this on there. I think they were trying to protect their design from being copied. Doesn't make a whole lot of sense, because if I can pull it off this easy, somebody that's copying the design should be able to do the same with no effort at all. Especially with higher quality tools, and who knows what they have access to if you're trying to rip somebody off. So we're just gently trying to pull it out from between the pins on the control chip. I'm not going to go crazy by the controller chip either. If you're going to do that, the best way to do it is just to replace the chip, because this stuff is underneath it and everywhere. But I'm just getting it off anywhere where it could make a short between two of the components on the top of the board. Alright, good enough. And that is what you're left with, a pile of nasty, whatever that is, some sort of potting / epoxy compound. And in between the pins on the chip, it's just going to be there. You're not going to get it out. Get all the excess that fell onto the board off, if you can. If you have an air hose on your workbench, now would be a great time to blow off the board, but I don't really have that much on there. Alright. Let's fire it up again and see what we get. Now the outputs for the main power supply, they're controlled by this board and everything on this side of the board. All the stuff on this side of the board is for the plus and minus, I believe it's 15 on this amp, plus and minus 15 volt supplies for the op amps. So this side is completely independent from this side. This connector here receives the feedback from the input board, and it says, hey, I need this much voltage to produce the sound. It sends that to this chip, and then this is basically just a buck power supply. And switch mode buck power supply. And that uses this inductor and this capacitor and these two transistors and these two diodes. So, I mean, it's not overly complicated. It's just a general basic power supply with a PWM controller on this board. And I think it's like class G, whatever uses rail tracking. But let's see if we still have 12 volts. Now, granted, that's only 4 volts high too. It's not like yeah, it's way out in the weeds, but it's just not what I expect it to be. That's why it's bothering me. I expect it to usually be between 7 and 8 volts. So let's check it again. We're still at 12 volts. So what I could do is I could swap the dashboard out and see if it is an issue with the dashboard. Or, let's see, this is a dashboard labeled RD. This is also an RD, so yeah, it's something you need to be careful of too if you're ever swapping parts between these boards. Let's pull this and discharge. And I think just as an example, since we're here, I will swap it. We might continue this one tomorrow too. We're already a ways in. I thought this was going to be much easier. Let's drain our caps. And I have a spare dashboard. So on these boards, for different models, they have this little resistor here on the side, and it's labeled RA, RB, RC, and RD. Well, depending on what model the amp is, they'll populate a different position on here. And all that does is it just tells you that some of the components in the circuit are just tweaked a little bit. Like the capacitor value might be different, a resistor value might be different. So if you're swapping these boards out, you got to make sure what revision it is, so you know that you're using the right board and the right amp. It'll work if you use a different one, but your outputs will be different. So it might sound different, might function different. Let's pull this guy out, put the other one in. If we still get 12 volts, I'm going to leave it in. And then we'll have to go to testing. I don't know what else it could be. It might just be that it's high, and that's the way it is. I'm not sure. 12 volts is new to me. Usually these put out 8 volts. I don't think it's going to be the end of the world, but you never know. Doesn't hurt to keep on trying. This one's already been kind of challenging, so might as well keep going with it. See what we can learn. You know, this is mainly to learn. That's why we're doing this. That's why I'm doing this. Every single one has a different problem and a different solution. Some of the failures are still the same, but other things can happen when it fails. I'm going to go back to my little bit larger tip. And we'll see what happens. It's very possible that something on the dashboard is not happy or was running too hot, or hard to tell. Almost up to temp. Now taking these boards off can be a little tricky, and I kind of use the wiggle method with those too. It seems to work best. You just got to be careful. You don't want to tear the through holes out. Once those through holes come out, it becomes a much more difficult job, especially if it ruins one of the ones on the top. So I'm going to give each pin a good amount of leaded solder, just to kind of help convince it to come loose. My test board's down right now. I still have to order those parts and get that back up and running, so we'll just swap the dashboards and see what happens. So first pin, I'm kind of wiggling it as much as I can, just to get that pin shaking a little bit so we can clear the solder out of the hole. And as you get more and more pins unsoldered, it wiggles a little more, so it gets easier as you go. And that is the proper way to pull out a bash control board. No damage to the PCB. Came out nice and clean. You can still see there's some residue underneath the chip. I don't know if this is good or bad yet, but we're going to pop a known good one in there, or at least what I think is a known good one, and check it. And what I'll end up doing is I'll make another video where I get my test fixture going again, and I'll replace that chip just so we can get all the rest of that gunk and epoxy off of there. I'm actually going to switch to the thinner solder for this because it just makes it a little easier. Just tack the first pin in place. Verify the alignment. I like to make sure the boards are straight up and down. I mean, I guess it doesn't really matter, but it just looks nicer if things aren't leaning all over the place. Alright. Now I start from the opposite side and work towards the pin I tacked. Try and get it done in the first shot so I don't have to come back. You know, leave a nice fillet on each one. Make sure there's no shorts. Alright. So bashboard has been replaced. And we are ready to test again. Let's turn off the irons. Make sure we are metal free. Get the solder out of the way, and let's see if we get 8 volts. If we get 8 volts, the dashboard has an issue. If it does have an issue, the first place I'm going to start is Q1, because that's where the glue was starting to turn brown. And luckily I have it on video, so I can go back and watch it and see where that was. If we still have 12 volts, I'm going to say that that's probably just this amp, and it wants to be at 12 volts. Alright, here we go. Ooh, we're at 7.9. No, this is where we want to be right here. 7.8, 7.9, 8, 8.1, in that range. So, dashboard, bad. We're going to label it too. Bad, maybe Q1. I'll put this with my test fixture, and we can go ahead and start reassembling this amp. If there's any more problems after this thing just doesn't want to be back in service. Alright, clean up our flux. We're not going to need that meter for a while. We're not going to need solder for a while. So we learned a few things tonight. We learned that, well, I think in one of my previous videos I covered that if you have full rail voltage that the outputs are blown. But we also learned that not changing the resistors, or at a minimum checking them on the amp board, can lead to catastrophic failure. We also learned that not having 8-volt output is a dashboard problem. Also that if the FETs are blown, we need to check the diode and the transistors on both sides. So we'll add those to our common checklist of things we do with every amp that comes in. Update my notes, and when we do another one of these, we will be prepared for what's likely going to be coming our way. This was kind of a fun one. Everybody learned something tonight too, so goals were met. I'm just going to secure this in the housing. I'm not going to bolt everything down until I get a test on it, and I'm still going to do a like a burn-in test, a heavy-duty test on this. I want to definitely make sure that everything is happy after going through all that. Start off all of our screws for the plate loose. That way we can come back and get them into the plastic standoffs. The plastic standoffs are always a pain. I am going to hit that dashboard with a blob of epoxy. You can see the blob that I took off. Is it needed? Probably not. But from the factory they had that lovely nasty brown glue on there, so I feel like if they had it fixed on there, it probably helps minimize the stress due to vibrations, so I will de-stress it too. I just won't use nasty glue that does more harm than good. Alright, snugging up our brass screws. And I'm going to remake the connections. CD minus, CD plus. Verify that our amp is going to the right spot on the amp board. Our power supply. Power supply goes to this side, feature board goes to the top. On this amp, if you screw it up, you won't blow anything. On other amps, you will. I don't remember exactly which ones. But, alright. Our ceramic heat sinks are in place. Nothing is touching metal. Go ahead and pop the feature board in. Speaker is already connected. We're going to make sure he is out of the way. Don't want him shorting out to anything. Alright, speaker is out of the way. Feature board is connected properly. LCD is happy. I don't remember which way this displays. Let's get him in there. Alright. So I have no input hooked up. I do have the speaker hooked up. I'm not hooking up an input until I verify that the volume is at a reasonable level. We can throw our defective resistors away. We don't need those anymore. Alright, let's bring this amp back to life. Give them some power. Just double check that our connections are good. Nothing is shorted. Alright, here we go. That is much better. That's what we want to see. And here is why you don't have a speaker hooked up. One, my test speaker would be on fire right now. My wife would be down here trying to attack me, and the dog would probably be barking. We're going to take, I usually go to like 38 or 32. That's good enough. I always change everybody's settings before I give it back to them. LFE mode. Phase at 0. Turn the display brightness up so I can see it a little easier. And save the settings as music. And I don't do that to be a jerk. I do that so when they plug it in, and if they have the levels on their system high, it doesn't overdrive their woofer and blow it. I mean, it takes 10 minutes to get your settings back in there. So, everything seems to be functioning happily. The resistors on the amp board are ice cold, as they should be. So now we can give it an input. Line in. 50 hertz, let's go a little bit lower than that. 40 hertz. And I know you guys can't hear that, and I apologize, but that definitely sounds good to me. While we're at it, because I know that I want to be able to show this to some people, I'm going to make a note to order a little desktop oscilloscope so we can see the output and see a nice clean sine wave. Alright. Well, that about does it for this one. Took a little bit longer than expected, but we found some problems that we didn't know we were going to run into. Hopefully everybody can learn something from this. I know I did. Definitely going to be making sure that when I get the next batch of these in for repairs, I definitely change the resistors and check and make sure that none of those other failure points are having any problems. I've been doing this for a while, but you know, every time I work on an amp, I find something new, find something different, find a way that I can improve my process or my skills. So I'm continuously learning and hopefully getting better at what I do. So thank you guys for tuning in. Hope we had fun. Please remember to subscribe and like, and I'll be back soon with another repair video. All right, thanks and good night.